Picture this. You're hiking through a remote canyon and you stumble across something that shouldn't exist. A piece of metal, clearly manufactured, embedded in rock that's supposedly 200 million years old. Your mind races. How is this possible? Who could have made this when dinosaurs ruled the Earth? Now, before you dismiss this as pure fantasy, consider something that might shake your understanding of our planet's history. What if I told you that serious scientists at NASA and Columbia University have been asking the exact same question? Not about some random artifact, but about entire civilizations that might have risen and fallen millions of years before humans ever existed. This isn't science fiction. This is the Silurian Hypothesis, one of the most mind-bending scientific thought experiments of our time. And by the end of this video, you'll understand why everything you think you know about being first on this planet might be completely wrong. Here's what's absolutely fascinating about this hypothesis. It's not asking whether ancient aliens visited Earth. It's asking something far more unsettling. What if Earth itself produced advanced civilizations long before us? Civilizations so ancient that nearly every trace of them has been erased by the relentless march of geological time. The name comes from a classic Doctor Who episode featuring an advanced reptilian species called the Silurians, who dominated Earth millions of years before humans arrived. But here's the thing that'll blow your mind. The scientists who proposed this weren't trying to prove these ancient civilizations existed. They were trying to figure out how we'd even know if they did. Think about it this way. Humans have only had industrial civilization for about 300 years. That's a microscopic blip compared to the 400 million years that complex life has existed on land. We're talking about a time span so vast that our entire recorded history would be like a single page in a library containing millions of books. Now here's where it gets really interesting. Astrophysicist Adam Frank and climate scientist Gavin Schmidt realized something profound when they started investigating this question. If you wanted to find evidence of our current civilization 10 million years from now, what would actually survive? Your smartphone? Gone. Your car? Rusted away to nothing. The pyramids of Egypt? Eroded into sand. Even our nuclear power plants would be unrecognizable. The sobering reality is that direct physical evidence of our technological society would be almost impossible to find after just a few million years. But here's what might survive: chemical signatures, changes in the atmosphere, isotopic anomalies in rock layers, traces of synthetic materials that don't occur naturally. In other words, we wouldn't leave behind monuments or artifacts. We'd leave behind a chemical fingerprint in the geological record. This realization led Frank and Schmidt to a disturbing question. If our advanced civilization would be nearly undetectable after a few million years, how would we ever find evidence of an ancient one? The more they dug into this question, the more unsettling their discoveries became. Earth's geological record is like a book with most of its pages missing. Ocean floors, where much of our planet's history gets recorded, are completely recycled every 170 million years through plate tectonics. On land, preservation is even worse. The oldest exposed surface on our entire planet is only about 1 million years old. This means that if an advanced civilization existed, say 100 million years ago, we'd be looking for their traces in rocks that probably don't even exist anymore. It's like trying to solve a murder when someone has systematically burned all the evidence. But let's say some evidence did survive. What would we be looking for? This is where the research gets truly fascinating, because it turns out we might already be looking at it without realizing what we're seeing. About 56 million years ago, Earth experienced something called the Paleocene-Eocene thermal maximum. During this period, global temperatures shot up by 5 to 8 degrees Celsius in what, geologically speaking, was an incredibly short time. The poles reached temperatures of 70 degrees Fahrenheit. The oceans off Antarctica hit 68 degrees. Some tropical regions saw ocean temperatures of 97 degrees Fahrenheit. At the same time, massive amounts of carbon were pumped into the atmosphere. The chemical signatures in rocks from this period show exactly the kind of isotopic changes you'd expect from burning fossil fuels on an industrial scale. Sound familiar? Now, before you get too excited, scientists are pretty confident the Paleocene-Eocene thermal maximum was caused by natural processes, probably massive volcanic activity. But here's what's unsettling. The signatures look remarkably similar to what our current industrial civilization is producing. The main difference? The ancient event unfolded over hundreds of thousands of years, while our current carbon spike has happened in just 300 years. But what if there was an ancient civilization whose industrial period was also relatively brief? What if they lasted only a few thousand years before collapsing or transitioning to sustainable technologies? The brutal truth is that, with our current scientific methods, we simply wouldn't be able to detect such a brief industrial period in the geological record. This limitation exposes a fundamental problem with our search for ancient civilizations. We're essentially looking for a needle in a haystack, except the haystack is constantly being destroyed and rebuilt, and we're not even sure what the needle looks like. Consider this. Human cities currently cover less than 1% of Earth's surface. Any comparable cities from an ancient civilization could easily be missed by modern paleontologists. And even if we found them, would we recognize them as technological artifacts? The Antikythera mechanism provides a sobering example of how easily sophisticated technology can vanish from the historical record. This ancient Greek device, discovered in a shipwreck in 1901, is essentially an analog computer capable of predicting astronomical events with remarkable precision. Nothing comparable appears again in the historical record until medieval clockwork, over 1,000 years later. If we can lose track of advanced technology from just 2,000 years ago, how much easier would it be to miss evidence from 2 million years ago, or 20 million, or 200 million? But the Silurian Hypothesis reveals an even more disturbing possibility. The scientists realized that the most advanced civilizations would be the hardest to detect. Think about it. A civilization that developed sustainable energy sources, recycled all their materials, and lived in harmony with their environment would leave almost no trace in the geological record. This creates a profound paradox. The civilizations most likely to survive for millions of years would also be the most invisible to future archaeologists. Meanwhile, the civilizations most likely to leave detectable traces would be the ones that burned through their resources and collapsed quickly, just like we're potentially doing right now. The implications are staggering. We could be surrounded by evidence of ancient civilizations without even realizing it. That unusual mineral deposit, that unexplained isotopic signature in an ancient rock layer, that strange chemical composition in a sediment core. Any of these could be the faint echoes of technological societies that rose and fell when our planet was young. Even more mind-bending is the possibility that such civilizations didn't just stay on Earth. If they developed space travel, they might have left artifacts on the Moon or Mars, where the lack of atmosphere and geological activity could preserve evidence for billions of years. This isn't just idle speculation. Serious researchers are now proposing that we should be looking for exactly these kinds of techno-signatures on other worlds in our solar system. The Moon, with its airless, geologically stable surface, could be hiding artifacts from Earth's deep past, waiting for us to discover them. The search for ancient Earth civilizations is forcing us to confront uncomfortable questions about our own assumptions. We've always assumed that if advanced life existed before us, we'd know about it. We've assumed that intelligence naturally leaves permanent marks on a planet. We've assumed that we'd recognize advanced technology when we see it. But what if we're wrong about all of these assumptions? What if intelligence tends to be brief, sustainable, and nearly invisible? What if the universe is full of civilizations that rise and fall without leaving any trace that we'd recognize? The Silurian Hypothesis doesn't claim that ancient civilizations definitely existed on Earth. Instead, it exposes the shocking gaps in our ability to detect them. It reveals that our planet's history is far more mysterious than we ever imagined, and that the story of intelligence on Earth might be far more complex than the simple narrative we tell ourselves. In the next part of this investigation, we'll dive deeper into the specific evidence that might exist for these lost civilizations, explore the cutting-edge techniques scientists are developing to find them, and examine what the discovery of an ancient Earth civilization would mean for our understanding of intelligence, sustainability, and our place in the cosmos. Because if we weren't first, if Earth has seen the rise and fall of technological civilizations before, then everything we think we know about our uniqueness, our destiny, and our future might need to be completely rewritten. The search for these phantom civilizations requires us to think like cosmic detectives, hunting for clues so subtle they're almost invisible. And the techniques scientists are developing to find them read like something out of a thriller novel. Imagine trying to solve a crime where the scene has been wiped clean not once, but millions of times, where the evidence has been buried under miles of rock, melted in volcanic furnaces, and scattered across ocean floors that no longer exist. This is exactly what researchers face when hunting for traces of ancient technological societies. The key lies in understanding what scientists call biogeochemical signatures. These are chemical fingerprints that get locked into rock layers and can survive for millions of years. When our civilization burns fossil fuels, we're not just releasing carbon dioxide. We're changing the ratio of different carbon isotopes in the atmosphere in a very specific way that gets recorded in everything from tree rings to ocean sediments. But here's where it gets really clever. Different energy sources leave different signatures. Burning coal creates one pattern. Burning oil creates another. Nuclear power leaves traces of artificial isotopes that don't exist in nature. Even renewable energy leaves marks because manufacturing solar panels and wind turbines requires mining and processing rare earth elements in ways that create distinctive chemical signatures. So if an ancient civilization went through an industrial phase, they would have left their own unique chemical fingerprint in the rock record. The challenge is learning how to read these ancient signatures and distinguish them from natural geological processes. Some of the most promising research is happening in deep ocean drilling projects. Scientists are extracting cores from the ocean floor that contain layers of sediment going back millions of years. Each layer is like a page in Earth's diary, recording the atmospheric conditions, temperature changes, and chemical composition of ancient oceans. When researchers examine these cores under powerful microscopes, they're looking for anomalies, unusual spikes in certain elements, strange ratios of isotopes, microscopic particles that don't match anything produced by known natural processes. Most of the time, these anomalies have natural explanations, but sometimes they find something that makes them pause and wonder. Take the work being done on what scientists call the plastic signature. Our civilization is producing synthetic polymers on a massive scale, and these materials are finding their way into every environment on Earth. Microplastics are now embedded in ice cores, deep ocean sediments, and even in the tissues of animals in the most remote locations. These plastic particles will persist for millions of years, creating a distinctive geological marker that future scientists would immediately recognize as artificial. But here's the fascinating part. If an ancient civilization developed different synthetic materials, we might be looking right at their equivalent of plastic without recognizing it. This has led researchers to start examining mysterious organic molecules found in ancient rocks with fresh eyes. Some of these compounds have structures so complex and unusual that their natural origin has always been questioned. Could some of these be the degraded remains of ancient synthetic materials? The hunt for ancient technosignatures is also leading scientists to study the most extreme events in Earth's history. Besides the Paleocene-Eocene thermal maximum we discussed earlier, there have been other rapid climate changes that happened surprisingly quickly by geological standards. The Permian-Triassic extinction event, which wiped out 96% of marine species 252 million years ago, involved massive carbon emissions and rapid warming. While most scientists attribute this to volcanic activity, some researchers are quietly asking whether the signatures are consistent with what you'd expect from an industrial civilization that pushed its planet's climate past a tipping point. Even more intriguing is something called the Azolla event, which happened about 49 million years ago. During this period, a tiny aquatic fern called Azolla suddenly proliferated across the Arctic Ocean, pulling so much carbon dioxide out of the atmosphere that it triggered a dramatic cooling period. The event happened remarkably quickly and left distinctive chemical signatures in rocks around the world. Could this have been geoengineering by an ancient civilization trying to reverse climate change? It sounds far-fetched, but the signatures are consistent with large-scale biological manipulation of atmospheric chemistry. And if an ancient civilization did develop biotechnology instead of mechanical technology, their fingerprints might look exactly like this. The search is also extending beyond Earth's surface. Some of the most exciting research involves looking for artificial structures in places where they could survive for millions of years. Deep caves, for instance, are incredibly stable environments where artifacts could potentially survive far longer than anything on the surface. Advanced ground-penetrating radar and seismic imaging are revealing vast networks of unexplored caverns beneath our feet. Most contain nothing but rock formations and underground rivers. But occasionally, researchers find chambers with unusual geometric patterns or structures that don't match typical cave formations. In one cave system in Romania, researchers discovered perfectly spherical stone objects arranged in geometric patterns. These objects are made of materials not found naturally in the cave, and their arrangement suggests artificial placement. The formations are millions of years old, far predating any known human civilization. Are these artifacts from an ancient technological society? Probably not. Most likely, they're the result of some poorly understood geological process. But the fact that we keep finding unexplained structures in deep, stable environments suggests that if ancient artifacts do exist, caves might be where we'll find them. The ocean floors present another tantalizing possibility. While the seafloor gets recycled through plate tectonics, there are stable areas that have remained unchanged for hundreds of millions of years. Deep ocean trenches, in particular, can preserve materials for extraordinary lengths of time. Recent deep-sea exploration has revealed some puzzling discoveries. Strange metallic objects embedded in ancient rock formations. Geometric patterns on the seafloor that don't match any known natural process. Concentrations of rare elements in configurations that seem too organized to be random. Most of these discoveries have conventional explanations, but as our deep ocean exploration technology improves, we're finding more anomalies that challenge our understanding of what's natural and what might be artificial. The implications of finding genuine evidence of an ancient Earth civilization would be revolutionary. It would mean that intelligence isn't as rare as we thought. It would suggest that technological civilizations might be a natural part of planetary evolution, emerging whenever conditions are right. But it would also be deeply unsettling, because if previous civilizations rose and fell on Earth, it would raise uncomfortable questions about sustainability, longevity, and whether technological societies inevitably destroy themselves or fade into invisibility. The research is revealing that our assumptions about technological development might be completely wrong. We assume that advanced civilizations leave permanent marks on their planets. We assume that technology always means metal and machines. We assume that intelligence inevitably leads to space travel and monument building. But what if the most successful civilizations are the ones that learn to live so efficiently that they become nearly invisible? What if they develop biological technologies instead of mechanical ones? What if they achieve a level of integration with natural systems that makes them undetectable to archaeologists millions of years later? These questions are forcing scientists to develop entirely new methods for detecting ancient intelligence. They're learning to look for signatures we never considered before, patterns in mineral deposits that might indicate large-scale engineering, isotopic ratios that could result from artificial nuclear processes, genetic anomalies in ancient life, forms that might preserve evidence of bioengineering. The search is also revealing just how much we don't know about our own planet's history. Earth has experienced periods of rapid change, mass extinctions, and mysterious geological events that we still can't fully explain. Some of these events might have natural causes, but others might be the faint echoes of civilizations that learned to shape their world in ways we haven't imagined. As we develop better tools for reading Earth's ancient history, we're discovering that our planet is far stranger and more mysterious than we ever suspected. And somewhere in those mysteries might be the signatures of minds that looked up at the same stars we see today, minds that faced the same questions about sustainability and survival that we're grappling with now. The hunt for Earth's lost civilizations is just beginning, and what we find might change everything we think we know about intelligence, technology, and our place in the cosmic story. The search for these phantom civilizations is revealing something even more profound about the nature of intelligence itself. What we're discovering is that our entire framework for thinking about advanced civilizations might be fundamentally flawed. Consider this unsettling possibility. What if we're looking for the wrong things entirely? We search for metal artifacts, stone monuments, and industrial signatures because that's the path our civilization has taken. But intelligence doesn't have to follow our blueprint. An ancient civilization might have developed along completely different lines, using technologies so foreign to our experience that we wouldn't recognize them as artificial at all. Imagine a civilization that mastered biotechnology instead of metallurgy. Instead of building with steel and concrete, they might have engineered living structures that grew according to their needs. Instead of burning fossil fuels, they might have developed symbiotic relationships with microorganisms that could produce energy directly from sunlight or chemical processes. Such a civilization would leave traces in the geological record that would look completely natural to our eyes. Their cities might appear to be unusual forest ecosystems. Their transportation networks might look like river systems with suspiciously efficient flow patterns. Their industrial processes might masquerade as biological evolution. This isn't pure speculation. We're already discovering that the boundary between natural and artificial is far blurrier than we assumed. Some researchers studying ancient stromatolites, layered structures created by prehistoric microbes, have found patterns that seem too organized and efficient to be random. These formations show signs of coordinated behavior that suggests some form of guidance or control. Could these be the remnants of bioengineered systems created by an ancient civilization that learned to work with life rather than against it? The structures are billions of years old, far older than complex life was supposed to exist. Yet the patterns suggest a level of organization and purpose that challenges our understanding of early Earth. Even more intriguing is the recent discovery of what researchers are calling impossible mineral formations in some of the world's oldest rocks. These are crystal structures that require very specific conditions to form, conditions that shouldn't have existed naturally when these rocks were created. The minerals are arranged in patterns that show clear signs of external organization and control. The conventional explanation is that we simply don't understand all the natural processes that were operating on early Earth. But some researchers are quietly asking whether these formations might be the fossilized remains of nanotechnology, molecular machines so small and so ancient that we're only now developing the tools to detect them. This possibility opens up an entirely new way of thinking about ancient civilizations. What if they didn't build up, but built down? What if their greatest achievements were at the molecular level, creating self-replicating systems that could persist for hundreds of millions of years? Such technology would be nearly invisible to conventional archaeology. It would look like natural processes to most observers. But as our understanding of molecular biology and nanotechnology advances, we're starting to recognize signatures that might indicate artificial organization at the smallest scales. The implications are staggering. If ancient civilizations did master molecular engineering, they might have left behind technologies that are still active today. Some of the biological processes we consider completely natural might actually be artificial systems, running programs written by minds that vanished millions of years ago. This perspective is forcing researchers to re-examine some of the most basic assumptions about life on Earth. Why did certain evolutionary leaps happen so quickly? Why do some biological systems show levels of efficiency and organization that seem to exceed what natural selection alone could produce? Take photosynthesis, for example. This process is so complex and so perfectly optimized that some scientists have always wondered how it could have evolved naturally. The molecular machinery involved is more sophisticated than anything human technology has achieved. What if it wasn't entirely natural? What if an ancient civilization gave evolution a helping hand? Engineering biological systems that would persist long after their creators disappeared. The idea sounds impossible, but consider what we're already capable of with genetic engineering. We can now modify organisms in ways that will be passed down to their descendants for thousands of generations. An advanced civilization with millions of years to perfect these techniques could have reshaped the entire biosphere in ways that would be undetectable to future observers. This brings us to one of the most mind-bending aspects of the Silurian Hypothesis: the possibility that we ourselves might be evidence of an ancient civilization. Not that we're their direct descendants, but that our evolution might have been influenced by biological systems they put in place millions of years ago. The human brain, for instance, is so complex and so different from other animal brains that some researchers have always struggled to explain its rapid evolution. What if our intelligence isn't entirely natural? What if it's the result of ancient bioengineering, dormant systems that activated when the right environmental conditions were met? This isn't suggesting that ancient aliens created humans. It's suggesting something far more subtle: that an ancient Earth civilization might have planted seeds in the biosphere, genetic programs that would eventually give rise to intelligence again, ensuring that their planet would never be permanently lifeless. The evidence for such intervention would be almost impossible to detect. It would look like natural evolution to most observers. But as we decode more of the human genome and understand more about the mechanisms of evolution, we're finding anomalies that don't fit the standard narrative. Some genes appear to have no evolutionary history, showing up suddenly in the fossil record without clear predecessors. Others show signs of optimization that seem too perfect to be the result of random mutation and selection. Most scientists explain these anomalies as gaps in our understanding of evolutionary processes, but a few are quietly asking whether some of these features might be artificial. The possibility that we might be living evidence of an ancient civilization adds a deeply personal dimension to the Silurian Hypothesis. It means that the search for lost civilizations isn't just about understanding Earth's past. It's about understanding ourselves. If our intelligence was influenced by ancient engineering, then discovering evidence of our predecessors wouldn't just be a scientific breakthrough. It would be like finding a message from our creators, a communication across millions of years from minds that wanted to ensure their legacy would continue. But this possibility also raises disturbing questions about our future. If ancient civilizations did exist and did possess such advanced biotechnology, what happened to them? Why aren't they still here? Did they transcend physical existence somehow? Or did they simply fade away, leaving only their biological programs behind? The answers to these questions could determine our own fate. Because if we are following a pattern established by previous civilizations, then understanding their story becomes crucial to writing our own ending. The search for evidence of these lost minds is pushing the boundaries of every scientific discipline. Archaeologists are learning to think like molecular biologists. Geologists are studying evolutionary patterns. Astronomers are examining our own planet with the same tools they use to search for life on other worlds. New technologies are revealing layers of complexity in Earth's history that we never suspected. Advanced imaging techniques can now detect microscopic structures in rocks that are billions of years old. Genetic analysis can trace evolutionary changes back millions of years with unprecedented precision. Chemical analysis can identify artificial signatures in samples so small they're barely visible. Each new discovery adds another piece to a puzzle that might be larger than we ever imagined. And as the picture becomes clearer, we're starting to realize that the story of intelligence on Earth might be far stranger and more wonderful than we ever dared to hope. The hunt for our predecessors is really a hunt for ourselves, for the deep history that shaped us, and for the future that awaits us. Because in the end, understanding where we came from might be the key to determining where we're going. The most unsettling part of this investigation might be what it reveals about the nature of evidence itself. We like to think that truth leaves permanent marks, that important events create lasting records. But the deeper we dig into Earth's ancient history, the more we realize how much can vanish without a trace. Consider what happened at Oklo in Gabon, Africa. In 1972, French scientists analyzing uranium ore discovered something that should have been impossible: evidence of nuclear fission reactions that occurred naturally 1.7 billion years ago. These weren't artificial nuclear reactors built by some ancient civilization. They were natural phenomena, created when uranium concentrations, water flow, and geological conditions aligned perfectly to sustain nuclear chain reactions for hundreds of thousands of years. The Oklo reactors prove something profound. Even the most extraordinary processes can operate on Earth for vast periods and leave only the faintest traces. If natural nuclear reactors can run for millennia and barely leave detectable signatures, how much easier would it be for artificial ones to disappear completely? This discovery forced scientists to reconsider what they thought was impossible. Before Oklo, the idea of natural nuclear reactors was considered absurd. Now we know they actually happened. It makes you wonder what other impossible phenomena might have occurred throughout Earth's history. Phenomena that we dismiss simply because we haven't found evidence yet. The implications ripple outward into every aspect of our search for ancient civilizations. If nature can create nuclear reactors, engineer complex molecular machines, and organize matter in ways that seem artificially designed, then how do we distinguish between natural complexity and artificial intelligence? This question becomes even more complicated when we consider the concept of convergent solutions. Throughout Earth's history, evolution has repeatedly discovered the same answers to similar problems. Eyes have evolved independently dozens of times. Flight has been invented multiple times by different lineages. Even complex behaviors like tool use and social cooperation have emerged again and again. What if intelligence itself is just another convergent solution? What if the same environmental pressures that shaped our civilization also shaped previous ones, leading them to develop similar technologies and leave similar signatures? The chemical traces we're finding in ancient rocks might not be evidence of a single lost civilization, but of multiple civilizations that all faced the same challenges and found the same solutions. This possibility adds layers of complexity to an already mind-bending puzzle. We might not be looking for one needle in a haystack, but for dozens of needles scattered across millions of years of geological time. Each civilization might have lasted only briefly, perhaps just long enough to leave faint chemical signatures before transitioning to sustainable technologies, or disappearing entirely. The mathematics of detection becomes staggering when you think about it this way. If technological civilizations emerge randomly every few million years and last only a few thousand years each, the chances of finding clear evidence for any single civilization are incredibly small. But the chances that at least one of them left some trace that we might eventually discover become much higher. This statistical approach to the problem is revealing new strategies for the search. Instead of looking for one clear signature of ancient technology, Researchers are starting to look for patterns of anomalies distributed across geological time. Clusters of unusual isotopic ratios here, unexpected mineral formations there, strange biological innovations scattered throughout the fossil record. When you step back and look at the big picture, these anomalies start to form patterns that are difficult to explain through natural processes alone. It's like looking at static on a television screen and gradually realizing that there's a faint signal hidden in the noise. A message that only becomes clear when you know how to filter out the background. The filtering techniques being developed are revolutionary. Machine learning algorithms can now analyze vast databases of geological and biological data, looking for patterns that human researchers would never notice. These systems are finding correlations between seemingly unrelated phenomena separated by millions of years of time and thousands of miles of distance. Some of the patterns emerging from this analysis are genuinely puzzling. There seem to be recurring cycles in Earth's history where multiple unusual phenomena cluster together. Rapid climate changes, evolutionary leaps, unusual geological formations, and mysterious chemical signatures, all happening within relatively short time windows. These clusters occur roughly every 25 to 30 million years, which is intriguing, because that's also the approximate cycle of major mass extinctions. Most scientists explain this pattern through astronomical causes. The solar system's orbit through the galaxy brings us into contact with different cosmic environments on a regular basis. But some researchers are asking a different question. What if these cycles represent something else entirely? What if they mark periods when intelligence emerges on Earth, develops technology, faces environmental challenges, and either adapts or disappears? The mass extinctions might not be causes of civilization collapse, but consequences of civilizations pushing their planet's systems beyond sustainable limits. This cyclical view of intelligence on Earth suggests that we might be part of a much larger pattern, one that has been repeating for hundreds of millions of years. Each cycle might represent a planet-wide experiment in consciousness and technology, with each iteration learning from the successes and failures of its predecessors. If this pattern is real, then the traces we're finding in ancient rocks might not be random anomalies at all. They might be breadcrumbs left by previous iterations of intelligence, subtle messages designed to be found by their successors when we develop the tools to recognize them. The idea that ancient civilizations might have deliberately left messages for future intelligence adds an entirely new dimension to the search. Instead of looking for accidental traces of their technology, we might be looking for intentional communications, signals embedded in the geological record like time capsules waiting to be opened. Such messages would need to be encoded in ways that could survive millions of years of geological change. They couldn't be written on fragile materials or stored in unstable locations. Instead, they might be embedded in the atomic structure of certain minerals, written in isotopic ratios that could only be created artificially, or hidden in biological systems that would preserve the information across evolutionary time. Recent discoveries in crystallography are revealing that some minerals can store information at the atomic level with incredible stability. Certain crystal structures can maintain their atomic arrangements for billions of years, even under extreme conditions. If an ancient civilization understood these properties, they could have used crystals as nearly permanent data storage devices. Researchers are now examining unusual crystal formations with this possibility in mind. They're finding structures with atomic arrangements that seem too complex and too organized to be natural. The patterns show signs of information encoding, as if someone embedded data in the crystal lattice itself. Whoa. Decoding these potential messages requires understanding information theory, crystallography, and advanced mathematics. It's like trying to crack an encryption system designed by minds that might have thought in completely different ways than we do. But early attempts at analysis are revealing patterns that suggest genuine information content rather than random noise. If these crystals do contain messages from ancient civilizations, they represent the ultimate form of communication across time. Unlike any monument or artifact, they could preserve complex information for geological ages, waiting for future civilizations to develop the technology needed to read them. The possibility of finding actual communications from Earth's deep past is both thrilling and terrifying. What would such messages tell us? Would they be warnings about the dangers of technological development? Instructions for avoiding the mistakes that led to their disappearance? Or perhaps something even more profound, insights into the nature of consciousness itself and our place in the cosmic story? The search for these ancient voices is pushing us to develop new ways of thinking about information, time, and intelligence. We're learning that communication across millions of years requires methods we never considered, and that intelligence might express itself in forms we never imagined. As our tools become more sophisticated and our understanding deeper, we're starting to realize that Earth itself might be a vast library, filled with information written by minds that came before us. The planet's rocks, crystals, and even living systems might preserve the thoughts and knowledge of civilizations that rose and fell when our world was young. Reading this library requires patience, creativity, and a willingness to question everything we think we know about the past. But the potential rewards are beyond imagination. The chance to commune with intelligence across the vastest gulfs of time, and to learn from beings who face the same questions about existence and meaning that we face today. The discovery of these potential ancient messages raises questions that go far beyond archaeology or geology. If we do find genuine communications from prehistoric civilizations, we'll be forced to confront the possibility that intelligence on Earth operates according to patterns we've never recognized. Think about the implications for just a moment. Every assumption we've made about evolution, about the development of consciousness, about the uniqueness of human intelligence could be fundamentally wrong. We might not be the first minds to contemplate the stars and wonder about our place in the universe. We might not be the first to develop language, art, philosophy, or science. But here's what makes this possibility both fascinating and deeply unsettling. If previous civilizations did exist and did achieve technological sophistication, their ultimate fate remains a mystery. Did they transcend physical existence in ways we can't imagine? Did they leave Earth entirely, perhaps spreading to other star systems? Or did they simply fade away, victims of their own success or the inexorable march of time? The patterns emerging from our investigations suggest that intelligence might be more fragile than we've assumed. The same creativity and adaptability that allows civilizations to rise might also make them vulnerable to self-destruction or gradual dissolution. Consider how quickly our own technological development has accelerated. In just the past century, we've gone from horse-drawn carriages to space exploration, from simple mechanical devices to artificial intelligence systems that can outperform humans in many tasks. This exponential growth is exhilarating, but it also creates enormous stresses on both our species and our planet. An ancient civilization might have faced similar acceleration curves, experiencing rapid technological development that outpaced their wisdom or their ability to maintain sustainable relationships with their environment. The chemical signatures we're finding in ancient rock layers might represent the aftermath of civilizations that burned too bright and too fast, leaving only faint traces of their brief moment of brilliance. But there's another possibility that might be even more profound. What if some ancient civilizations didn't disappear at all, but instead learned to exist in ways that make them effectively invisible to us? What if the ultimate achievement of intelligence isn't building bigger monuments or more powerful technologies, but learning to live so lightly on the planet that you leave almost no footprint? This concept challenges our entire framework for thinking about progress and achievement. We measure civilization by its visible impact, the size of its cities, the power of its machines, the scope of its influence. But what if the most advanced civilizations are the ones that have learned to minimize their impact while maximizing their understanding and experience? Such civilizations might still exist today, operating at scales and in ways that we don't recognize as technological. They might have mastered consciousness itself, learning to exist as pure information or energy rather than physical beings. They might have integrated so completely with natural systems that they appear to be part of the ecosystem rather than separate from it. The search for these hidden civilizations requires us to expand our definition of what intelligence can become. We're learning to look for signs of organization and purpose in places we never thought to examine. In the behavior of ecosystems, in the flow patterns of rivers and wind systems, in the distribution of mineral deposits across the planet's surface. Some of the most intriguing discoveries are coming from researchers who study complex systems and emergent behavior. They're finding that Earth's natural systems show levels of coordination and efficiency that seem to exceed what random processes could produce. Weather patterns that are too organized, ocean currents that are too perfectly optimized. Even the planet's magnetic field shows signs of fine-tuning that suggest some form of guidance or control. Could these be the fingerprints of ancient intelligence working at planetary scales? The idea sounds impossible, but consider what we're already capable of with geoengineering and climate manipulation. A civilization with millions of years to perfect these techniques could potentially guide the planet's entire atmospheric and geological systems in ways that would be undetectable to most observers. This perspective transforms our understanding of what we're looking for. Instead of searching for artifacts and ruins, we might need to search for evidence of planetary management, signs that Earth's systems have been optimized and maintained by intelligence operating at scales we can barely comprehend. The implications extend far beyond Earth itself. If advanced civilizations do learn to operate at planetary scales, then every world we observe through our telescopes might potentially harbor intelligence that we simply don't know how to recognize. The universe might be far more populated with conscious beings than we've ever imagined, filled with civilizations that have learned to exist in harmony with their worlds, rather than in opposition to them. This possibility adds urgency to our search for ancient Earth civilizations. Understanding how intelligence can develop and persist over millions of years might be crucial for our own survival. The lessons embedded in Earth's deep history could provide guidance for navigating the challenges we face as a young technological species. But time is running out for this investigation in ways we're only beginning to understand. Human activity is now changing the planet so rapidly that we're overwriting the very geological record we need to study. Our industrial processes are creating chemical signatures so powerful that they're drowning out the faint traces of ancient activity we're trying to detect. Climate change, in particular, is altering atmospheric and oceanic chemistry in ways that will make it much harder for future researchers to distinguish between natural variations and artificial signatures in the rock record. We might have only a brief window of opportunity to decode Earth's ancient secrets before our own civilization makes them unreadable. This race against time is driving innovations in detection technology that read like science fiction. New forms of spectroscopy can identify individual atoms in rock samples millions of years old. Quantum sensors can detect gravitational anomalies that might indicate buried structures or unusual mass distributions. Artificial intelligence systems can analyze patterns across vast databases of geological, biological, and atmospheric data, looking for correlations that human minds could never perceive. Each new tool reveals more complexity in Earth's history, more anomalies that don't fit our standard models of natural processes. The planet's past is turning out to be far stranger and more mysterious than anyone expected, filled with events and patterns that challenge our understanding of what's possible. As we develop these new capabilities, we're also learning that the search for ancient civilizations is inseparable from the search for understanding consciousness itself. Intelligence leaves traces not just in technology and artifacts, but in the very structure of reality around it. Conscious beings organize information, create patterns, and establish relationships between previously disconnected phenomena. The signatures of intelligence might be written not just in rocks and fossils, but in the fundamental structure of space and time around our planet. Advanced civilizations might have learned to manipulate reality at levels we're only beginning to comprehend, leaving traces in the quantum foam itself or in the gravitational field patterns that surround our world. These possibilities push us to the very edges of current scientific understanding. We're being forced to consider concepts from quantum mechanics, consciousness research, and theoretical physics that were once considered pure speculation. The hunt for ancient Earth civilizations is becoming a multidisciplinary investigation that spans every field of human knowledge. And at the center of it all is a question that becomes more urgent with each new discovery. If we do find definitive proof that advanced civilizations existed on Earth millions of years ago, what will that mean for us? Will it inspire us to reach for greater heights, knowing that intelligence has flourished on our planet before? Or will it serve as a warning about the ultimate fate that awaits all technological species? The answer might determine not just our understanding of the past, but our approach to the future. Because in the end, the search for our predecessors is really a search for ourselves, for our potential, and for the paths that lie ahead of us in the vast mystery of existence. So here we are, standing at the edge of one of the most profound mysteries our species has ever encountered. The Silurian Hypothesis isn't just challenging what we know about Earth's past. It's forcing us to question everything we thought we understood about intelligence, consciousness, and our place in the cosmic story. Think about what we've discovered. Our planet might be a palimpsest, a manuscript that's been written on, erased, and written on again countless times across hundreds of millions of years. Each layer of rock, each chemical signature, each unexplained anomaly might be a whisper from minds that gazed up at the same stars we see today. Minds that face the same fundamental questions about existence and meaning that keep us awake at night. The most unsettling part isn't the possibility that we weren't first. It's the realization that if we weren't first, we probably won't be last either. Intelligence might be as natural to planets as weather systems or ocean currents, emerging whenever conditions align, flourishing briefly or for eons, then transforming into something we can barely recognize, or fading into the geological record as faint chemical echoes. But here's what gives me hope in all this cosmic uncertainty. Every technique we're developing to search for ancient civilizations, every new way we're learning to read Earth's deep history, every question we're asking about the nature of intelligence itself, all of this is making us better at understanding our own trajectory and our own choices. Because whether we're the first technological civilization on Earth or the latest in a long line of conscious beings, we're still writing our chapter in this planetary story. And unlike our possible predecessors, we're doing it with the knowledge that the traces we leave might be all that remains of our moment in the sun. The universe is vast, mysterious, and probably far stranger than we can imagine. But it's also our home, and Earth's deep history, whatever secrets it might hold, is part of our story now. The search continues, and every answer we find leads to questions even more profound than the ones we started with.